In this problem, we have given that this question has statement 1 and statement 2. Of the four choices given after the statements, choose the one that best describes into two statements. Statement 1 has higher the range, greater is the resistance of ammeter. And statement 2 is to increase the range of ammeter, additional shunt needs to be used across it. Okay, so we can see that we want to obtain an ammeter. Okay, and we can obtain it by connecting a galvanometer and a shunt in parallel with it. Okay, so if we are going to connect a galvanometer and a shunt, both are in parallel combination, then we will find an ammeter. Okay, so consider the ammeter has current I. Okay, initially, and we want to increase the range. That means we want to increase the magnitude of current. This is the purpose. Okay, so what we will have to change in the shunt resistance. Okay, so first of all, we have given in statement 1, higher the range, greater is the resistance of ammeter. So higher the range means current is high. Okay, current is a magnitude of current across the ammeter is increased. So we know that if this is the current Ig. Okay, and this will be the current I minus Ig, then we can write Ig into Rg, that is the resistance of galvanometer, that is equals to I minus Ig multiplied by S. Okay, so from here S Ig into Rg equals to I into S minus Ig into S. Okay, now we can write Ig into Rg plus Ig into S upon S equals to I. Okay, so where S is the shunt resistance, so if we are going to increase the value of S, the current will decrease. Okay, the range will decrease, and we have given that higher the range, greater is the resistance of an ammeter. So from here we can say that for higher range, that means for higher range, the resistance of ammeter should be less. Okay, resistance of ammeter should be less, and for this the shunt resistance should also be less. Okay, or should also be decreased. So from here we can say, after the observation, that statement 1 is wrong. Okay, now let's talk to statement 2. To increase the range of ammeter, additional shunt needs to be used across it. Okay, so as we can see that shunt is connected in parallel combination with galvanometer. Okay, so if we are changing this shunt resistance to S dash by increasing it, so we are adding X resistance in S to increase it up to S dash. Okay, so in parallel combination, the value of S dash will be less than S. Okay, so as we know that S, when S will decrease, the current will increase. Okay, because this is in parallel combination, and from here we can say that 1 upon X plus 1 upon S will be equals to 1 upon S dash. Okay, so from here we can see that 1 upon X will be 1 upon S dash minus 1 upon X will be 1 upon S dash minus 1 upon S. So from here we are going to add X, but the new resistance will be decreasing. Okay, so if we are going to add or increase the range of ammeter, additional shunts need to be used across it. That means that is the correct answer, because when we are going to increase the resistance, the range of the ammeter will increase, because if the shunt resistance, the equivalent shunt resistance will decrease, so equivalent resistance of the ammeter will decrease and the range will increase. So we can say that statement 2 statement 2 is correct. So from here we can conclude that statement 1 is false and statement 2 is true. That means option D is the correct answer of this problem. Thank you.
Hello, we are given with a question, and the question says in a meter bridge experiment, null point for an unknown resistance is measured. Now, the unknown resistance put inside an enclosure maintained at a higher temperature. The null point can be obtained at same point as before by decreasing the value of standard resistance. Resistance of metal increases with increase in temperature. So, statement 1 asks resistance, statement 2 resistance of metal increases with increase in temperature. So yes, since resistance is directly proportional to temperature, resistance increases, right? So R by X, the null point, is equal to L1 by L2, right? So the value of the null point at is should not be changed according to this point, right? If that should not change, R by X also should not change. So it should not change, right? So if X is if X increases, R also should increase. So this statement is false. So what is our answer? Statement 1 is false and statement 2 is true. So option D is the correct answer. Thank you.
Hello students, our question gives that consider two identical galvanometers and two identical resistors with resistance R. If the internal resistance of the galvanometer is Rc is less than R by 2, which of the following statements about any one of the galvanometer is true? Okay, four options are given here. So we can analyze each option one by one. Here, in the first two options, it is said about the maximum voltage range. So, in the first option A, it is said that maximum voltage range is obtained when all the components are connected in series. And in second option, it is mentioned the maximum voltage range is obtained when the two resistors and one galvanometer are connected in series and the second galvanometer is connected in parallel to the first galvanometer. Okay, so we can analyze the first two statements. For a conversion of the voltmeter, the galvanometer is connected and a resistor is connected in series with the galvanometer. So, galvanometer can be converted into voltmeter or ammeter. For the conversion of voltmeter, the resistance should be connected in series. So, what happens when resistor is connected in series? What happens is that we get the maximum voltage. The resistance increases and we get the maximum voltage. But in the case of the parallel connection, what happens is that the resistance decreases. So, to conversion or to get the maximum voltage range, the resistance should be connected in series. So, comparing A and B, our statement A is true because here all the components are connected in series. Okay, let's check C and D. Here it is said the maximum current range is obtained when all the components are connected in parallel with both resistors. And option D gives the maximum current range is obtained when the two galvanometers are connected in series and the combination is connected in parallel. So here also on the conversion of a ammeter, on the conversion of ammeter, galvanometer into ammeter, the galvanometer is connected with the resistance called a shunt resistance parallelly. This is a shunt resistance parallelly for the conversion of ammeter. And this value of the shunt resistance should be least value. So to get a least value, the resistors should connected in parallel manner. So out of C and D, here the maximum current range is obtained when the resistors are connected in series manner. So the C options are true and option A is true. So our correct answer are the option A, the maximum voltage range is obtained when the components are connected in series. And option C, the maximum current range is obtained when the components are connected in parallel with the both resistors. Okay.
Hello students, our question is a microammeter has a resistance of 100 ohm and full scale range of 50 microampere. It can be used a voltmeter or as a higher range of ammeter, provided a resistance is added to it. Pick the correct range and resistance combination. So, these four are our options. Now, we have G is equal to 100 ohm and Ig is equal to 50 into 10 raised to minus 6 ampere. To use given galvanometer as an voltmeter, a large resistance should be connected in series. So, from our first option, assume that V is equal to 50 volt. So we know for finding resistance, RV is equal to V by Ig minus G. Here V is 50 volt. Divide by Ig is 50 into 10 raised to minus 6 minus G is 100. So finally we will get RV is equal to 9999900 ohm, which is approximately 10 raised to 6 ohm. Now, from our second option, we will take V is equal to 10 volt. So our RV will be V is 10 divided by Ig 50 into 10 raised to minus 6 minus 100. Our final answer will be 199900 ohm, which is approximately 200 kilo ohm. Now, to use given galvanometer as an ammeter, a shunt resistance S should be connected in parallel. So, from our third option, we will take I is equal to 5 milliampere. For finding shunt resistance, S is equal to Ig into G divided by I minus Ig. Here Ig is 50 into 10 raised to minus 6 and G is 100. I is 5 milliampere. So 5 into 10 raised to minus 3 minus 50 into 10 raised to minus 6. Our final shunt will be 1.01 ohm, which is approximately 1 ohm. And from our last option, we will take I is equal to 10 milliampere. So S will be 50 into 10 raised to minus 6 into 100 divided by 10 into 10 raised to minus 3 minus 50 into 10 raised to minus 6, which is 0.5 ohm. Now, we will see our options. So option A says when we take resistance or voltage 50 volt, then our range of resistance will be 10 kilo. But here our range of resistance is 10 raised to 6 ohm. In option B, if we take 10 volt, then our range will be 200 kilo ohm, which is correct. But in option C, if we take I is equal to 5 milliampere, then our range of resistance will be 1 ohm. which also is correct. So, C is also correct. When we take 10 milliampere, then our range will be 1 ohm. This is wrong because our range is 0.5 ohm. So, for this question, if this microammeter is used as voltmeter, so option B will be correct. And if it is used as a ammeter, so option C will be correct. But here question asked for both, so our answer will be B and C both correct. Okay?
तो इस क्वेश्चन में हमको क्या गिवन है, एक गैल्वेनोमीटर दे रखा है जो कि फुल स्केल डिफ्लेक्शन दे रहा है, कब, जबकि उसके थ्रू एक 0.006 एम्पेयर का करंट पास हो रहा है। ठीक है, अब हम क्या काम कर रहे हैं, उस गैल्वेनोमीटर को एक वोल्ट मीटर में कन्वर्ट कर रहे हैं। कैसे? इतने वैल्यू ऑफ रेजिस्टेंस को लगा करके सीरीज। ठीक है, उस वोल्ट मीटर की हमें रेंज दे रखी है 0.30 वोल्ट। अब सेकंड पार्ट में क्या गिवन है कि इफ कनेक्टेड टू दिस मच अमाउंट ऑफ रेजिस्टेंस, वो जो है एक अमीटर में कन्वर्ट हो जा रहा है, कितनी रेंज का, 1.5 एम्पेयर का। ठीक है, तो हमें वैल्यू ऑफ एन बतानी है। तो देखो हो क्या रहा है, इनिशियली हमारे पास क्या है, हमारे पास एक गैल्वेनोमीटर जी है। ठीक है, जिसका हमें फुल स्केल डिफ्लेक्शन बताया, मतलब कि उसके अंदर से जो करंट फ्लो कर सकता है वो है 0.006 एम्पेयर। ठीक है, अब हम क्या काम करते हैं, उसमें उसके सीरीज में हम एक रेसिस्टेंस लगा देते हैं जिसकी वैल्यू है 4990 ओम। ठीक है, अब वो कन्वर्ट हो जाता है। अब ये पूरा का पूरा जो सिस्टम है वो एक वोल्ट मीटर में कन्वर्ट हो जाता है, जिसकी रेंज हमको दे रखी है V इज इक्वल टू 0.30 वोल्ट। ठीक है, तो हम क्या काम करते हैं, हमें P पॉइंट और Q पॉइंट के अक्रॉस पोटेंशियल दे रखा है, वो है VPQ दैट इज इक्वल टू 0.30 वोल्ट। ठीक है, तो 0.30 किसके बराबर होगा, वो होगा आपके IG इंटू द रेसिस्टेंस ऑफ गैल्वेनोमीटर, जिसको हम G मान रहे हैं, प्लस 4990 इंटू IG। तो यहां से हमारा G की वैल्यू आ जाएगी, वो आएगी 0.30 माइनस 4990 इंटू 0.006 टोटल डिवाइडेड बाय 0.006। तो हमारे जो सॉल्व करने पे आएगी, वो हमारी जो वैल्यू आ जाएगी वो आ जाएगी 5000 ओम। ठीक है, तो हमारी जी की वैल्यू आ गई। अब वो क्या कह रहा है, सेकंड पार्ट में वो ये बोल रहा है कि अगर उसी को हम क्या काम कर रहे हैं, कनेक्ट कर रहे हैं पैरेलल में एक रेजिस्टेंस, तो वो कन्वर्ट हो जा रहा है एक अमीटर में। तो हमारे पास जो गैल्वेनोमीटर है उसको हम एक अमीटर में कन्वर्ट कर रहे हैं। तो कैसे कर रहे हैं, एक शंट लगा रहे हैं उसके पैरेलल में। तो शंट की जो वैल्यू गिवन है वो हमको दे रखी है कितनी, वो दे रखी है हमको 2n/249। तो ये S की वैल्यू दे रखी है 2n/249 ओम। ठीक है, तो हमको क्या गिवन है, हमें IG पता है, IG है 0.006 एम्पेयर। ठीक है, तो अब होगा क्या, इस A और B के अक्रॉस क्या होगा, पोटेंशियल क्या होगा, बराबर होगा। तो VA मस्ट बी इक्वल टू, मतलब VAB जो होगा क्या, वो होगा पोटेंशियल अक्रॉस शंट एंड गैल्वेनोमीटर, जो कि दोनों क्या होंगे, बराबर होंगे। मतलब कि पोटेंशियल अक्रॉस शंट मस्ट बी इक्वल टू पोटेंशियल अक्रॉस गैल्वेनोमीटर। और पोटेंशियल कैसे निकालेंगे, तो पोटेंशियल अक्रॉस शंट हो जाएगा रेसिस्टेंस ऑफ शंट इनटू द करंट वैल्यू। अब हमें जो रेंज दे रखी है, रेंज का मतलब क्या है, जो टोटल वैल्यू ऑफ करंट है वो कितना आ जा रहा है, वो जा रहा है 1.5 एम्पेयर। ठीक है, तो अब जो हमारा शंट के अक्रॉस जो करंट होगा वो हो जाएगा 1.5 माइनस 0.006 एंड दैट मस्ट बी इक्वल टू गैल्वेनोमीटर का रेसिस्टेंस वो कितना है 5000 ओम इनटू रेसिस्टेंस कितना है उसका 0.006। तो हमारी जो S की वैल्यू आ जाएगी वो आ जाएगी हमारी 5000 इंटू 6 इंटू 10 टू द पावर ऑफ -3 डिवाइडेड बाय 1.5 माइनस 0.006। तो जब इसको सॉल्व करेंगे तो हमारे जो शंट की वैल्यू आ जाएगी वो आ जाएगी 60 बाय 1494 और हमें S की वैल्यू कितनी दे रखी है, S की वैल्यू दे रखी है 2n/249। ये किसके बराबर है 2n/249 के। तो फाइनली हमारा जो n है वो क्या निकल के आ जाएगा, n वो आ जाएगा हमारा 60 इंटू 249 डिवाइडेड बाय 1494 इंटू 2। तो फाइनली आ जाएगा आपका आंसर 2490 डिवाइडेड बाय 498। ये हमारी वैल्यू ऑफ n निकल के आ जाएगी फाइनली।
Hello. The question says R1, R2, R3 are different values of R. A, B, C are the null point obtained corresponding to R1, R2 and R3 respectively. For which resistor the value of X, the unknown resistance X, will be most accurate and why? So we are asked about the value of resistance for which we will get the unknown resistance with most accuracy. Therefore, the error of X must be minimum. Now you see, we know in a potentiometer, X upon R is equal to L upon 100 minus L. Here we are measuring L from this end. Now, from this expression, we can find one thing very common. So, from this expression, we can get if R is large, if the value of R is large, then what will happen to the length L? Just look at here. On the left hand side, the denominator is very large. That means this value, the overall value will be very small. So upon calculation, this L will also be small. Hence, if R is large, then L is small. Similarly, if R is small, that means the denominator on this side is small, which means the overall value will be large. Since the overall value is large, upon calculation, we will get the value of L. The value of L as large value. Now this thing is common from this equation. Now from this equation, let's write the equation for relative error of X. So we can write this as X equals to R times L upon 100 minus L. Or from here we can write del X by X is equals to del R by R plus del L by L plus del 100 minus L upon 100 minus L. Now this on simplification will give us del X is X times del R upon R plus del L upon L plus del 100 minus L upon 100 minus L. This value will be known. the value of this R will be known, and we will see the relation in the other two. So if the value of R is very large, if the value of R is large, then this L will be very small. Okay, since this L will be very small, the overall value of this expression del L by L will be very large. That means ultimately this error of x, the error in x, the error while calculating the unknown value will be large. Similarly, if R is very small, if R is very small, then this L is very large. Then this L will be very large. Since this L is large, so 100 minus L will be very small, and this value will become, the overall value will become very large. Hence, it will impact the error in X in a big way. Now one thing is clear from here is that the balancing length should be somewhere in the middle, so that we get a very good accuracy in measuring X. Now, the middle point among A, B, C is the point B. Therefore, B must be the point. B must be the null point for highest accuracy. Highest accuracy among A, B, and C. So B point must be the null point for highest accuracy. Now corresponding to B point, we have resistance R2. Hence for resistance R2, the value of X will be most accurate. Thank you. Hello. The question asks, draw a circuit for experimental verification of Ohm's law using a source of variable DC voltage, a main resistance of 100 ohms, two galvanometers, and two resistances of value 10 to the power 6 omega and 10 to the power minus 3 omega respectively. Clearly show the position of the voltmeter and the ammeter. Now, in this question, we are asked to draw the circuit. This variable DC source is connected with a main resistance of 100 ohms. We have two galvanometers. So we all know that ammeter and voltmeter are basically two galvanometers only. So only variation that comes in galvanometer as ammeter or as voltmeter lies in the way the resistance is connected, also the value of the resistance is connected. So basically we have two galvanometers and we have two resistances. Now we also know that ammeters are always connected in series to a circuit and voltmeter are connected in parallel to a circuit. Now whenever we form a voltmeter from a galvanometer, what we do is we connect the galvanometer in series with the resistance, and the value of the resistance is very high. So here we will connect the galvanometer with a series resistance, and that value of resistance will be very high. So this is about the voltmeter. So first of all, voltmeter will be connected in parallel to the circuit. And secondly, while constructing the voltmeter, the galvanometer the galvanometer must have a resistance in series with it. Now to form the ammeter. Now to form the ammeter, what we do is, first of all, we know the ammeter must be connected in series to the circuit. So here the galvanometer must be connected in series to our circuit, and we connect the resistance. We connect a small resistance parallel to this galvanometer. We will connect a resistance parallel to this galvanometer, and the value of that resistance will be very small. That value in this question, so it is crystal clear from here that which resistance will connect in which branch. So this is our final circuit. Here, this is a galvanometer and this is a galvanometer. This is the main resistance. The main resistance given here is 100 omega. And now, since this is connected, we have connected this galvanometer as voltmeter, therefore the value of this resistance will be high. That is, this value will be 10 to the power 6 omega. And since this voltmeter is connected as an ammeter, therefore the value of this resistance will be small, which is 10 to the power minus 3 omega. If I name it, this will be your ammeter and this will be your volt. Thank you.
A thin uniform wire AB of length 1 meter, an unknown resistance X and a resistance of 12 ohm are connected by a thick conducting strips. हमें क्वेश्चन में एक वायर दिया हुआ है जो कि यूनिफॉर्म है और उसकी लेंथ जो है हमें 1 मीटर दी हुई है और साथ में हमें एक अननोन रेसिस्टेंस दिया हुआ है X और एक और रेसिस्टेंस दिया हुआ है जिसकी वैल्यू जो है वो हमें 12 ओम पता है और इसको कनेक्ट किया गया है कुछ थिक कंडक्टिंग स्ट्रिप्स से। आप इस डायग्राम में देख सकते हो, ये पार्ट हमारा ए भी है, ये अननोन रेसिस्टेंस है और ये नोन रेसिस्टेंस 12 ओम का है। ए बैटरी एंड ए गैल्वेनोमीटर विथ ए स्लाइडिंग जॉकी कनेक्टेड टू इट आर आल्सो अवेलेबल। हमारे पास एक बैटरी और एक गैल्वेनोमीटर भी अवेलेबल है जिसमें एक स्लाइडिंग जॉकी उससे कनेक्टेड है। ठीक है, अब हम लोग से क्या पूछा गया है, कनेक्शंस आर टू बी मेड टू मेजर द अननोन रेसिस्टेंस एक्स यूजिंग द प्रिंसिपल ऑफ व्हीटस्टोन ब्रिज। हमें जो कनेक्शन करना है वो इस तरीके से करना है कि व्हीटस्टोन ब्रिज के प्रिंसिपल को अप्लाई करके उस अननोन रेसिस्टेंस एक्स की वैल्यू जो है हम फाइंड आउट कर सकें। तो अब आंसर द फॉलोइंग क्वेश्चन, तो हमें इन दोनों क्वेश्चंस का आंसर करना है। आर देयर पॉजिटिव एंड नेगेटिव टर्मिनल्स ऑन द गैल्वेनोमीटर? क्वेश्चन ये है कि पॉजिटिव और नेगेटिव टर्मिनल्स होता है क्या गैल्वेनोमीटर में? तो आंसर तो बिल्कुल आसान है, नहीं, नो। क्यों? आखिर गैल्वेनोमीटर में क्या होता है? गैल्वेनोमीटर में एक ये एरो ये बताता है डिफ्लेक्शन को। ठीक है, ये डिफ्लेक्शन इनिशियली जब करंट फ्लो नहीं कर रहा होता है तो ये जीरो पे रहता है और अगर हम लोग इस गैल्वेनोमीटर से करंट फ्लो करवाते हैं तो हमें इस नीडल में डिफ्लेक्शन देखने को मिलता है। अगर आप करंट का डायरेक्शन ये रखोगे तो ये नीडल जो है वो इस डायरेक्शन में डिफ्लेक्ट होगा और वही अगर आप करंट का डायरेक्शन जो है वो उल्टा रखोगे यानी कि इस साइड, तो ये डिफ्लेक्शन जो है वो इस तरफ होगा। ठीक है, ये गैल्वेनोमीटर होता है। अब दूसरा क्वेश्चन क्या कह रहा है, कॉपी दैट फिगर इन योर आंसर बुक एंड शो द बैटरी एंड द गैल्वेनोमीटर विथ जॉकी कनेक्टेड एट अप्रोप्रिएट पॉइंट्स। हमें इस फिगर में बताना है कि बैटरी और गैल्वेनोमीटर का किस तरीके से कनेक्शन हम लोग करेंगे। तो ये भी एक आसान सा चीज़ है। अब क्या ये कनेक्शन आपको, ये वायर है ए बी, ठीक है, इस पॉइंट से फिर रेसिस्टेंस कनेक्टेड है एक्स, और फिर इस पॉइंट से रेसिस्टर कनेक्टेड है 12 ओम का, ठीक है। ये पॉइंट हमारा डी हो गया और ये स्ट्रिप है। अब जो है कनेक्शन करते वक्त गैल्वेनोमीटर को व्हीटस्टोन ब्रिज से अगर हम लोग को एक्स की वैल्यू निकालनी है तो हमें कुछ सी के थ्रू गैल्वेनोमीटर कनेक्ट करके कुछ इस वायर में कनेक्ट करना होगा। मैं करके दिखाता हूँ। इस पॉइंट सी से हम लोग क्या करेंगे, गैल्वेनोमीटर को कनेक्ट करेंगे और इसके जॉकी को हम लोग किसी पॉइंट पे, इस वायर के अलोंग किसी पॉइंट पे हम लोग मीट करवाएंगे, ठीक है। ये पॉइंट जे है, ये जॉकी के लिए मैंने जे लिख दिया। और बैटरी को हम लोग क्या करेंगे, यहाँ से इसके अक्रॉस ए और बी के अक्रॉस लगाएंगे। तो अब आप गौर से देखो, इसको व्हीटस्टोन ब्रिज के रूप में आप देख पा रहे हो। मैं दिखाता हूँ। ये पॉइंट हमारा ए है, ठीक है, ये पॉइंट ए है। उसके बाद इससे मैं कनेक्ट कर रहा हूँ पहले तो जे को, ये पॉइंट हमारा जे हो गया, ये पॉइंट हमारा सी है और ये पॉइंट हमारा बी है, ठीक है। तो अब ए से लेके बी तक का जो लेंथ है वो 100 सेंटीमीटर है। क्वेश्चन में भी दिया हुआ था 1 मीटर लेंथ है इसकी। और ये जो ए पॉइंट है वहां से बी को एक बैटरी कनेक्टेड है, ठीक है, इसकी वी वोल्ट मान लेते हैं कुछ। और ये जो ए पॉइंट है और ये डी पॉइंट एक दूसरे से कनेक्ट होने के कारण इस डायग्राम में एक दूसरे से डायरेक्टली कनेक्टेड है। तो मैं इन दोनों पॉइंट को एक साथ मान ले रहा हूँ, ये दोनों पॉइंट एक ही पॉइंट है। अब सी से बी तक हमारे पास इस डायग्राम में आप देखो तो क्या कनेक्टेड है, सी से जे तक गैल्वेनोमीटर, और ये जॉकी जो है वो जाके यहाँ पे कनेक्ट हो रहा है। अब ये जो रेसिस्टेंस है और ये जो रेसिस्टेंस है वो हमें पता है, ये कितना 12 ओम डी से सी के बीच में, और ये x ओम। अब क्या होगा कि ये जो पार्ट है ए टू जे इसका भी अपना कुछ रेसिस्टेंस होगा, और ये जो पार्ट है जे टू बी इसका भी अपना कुछ रेसिस्टेंस होगा। तो हम लोग दिस बाई दिस रेसिस्टेंस ऑफ ए जे इज इक्वल टू एक्स बाई रेसिस्टेंस ऑफ जे बी करेंगे ना, तो वहाँ से x की वैल्यू निकल जाएगी। वो वैसा क्यों किए, क्योंकि गैल्वेनोमीटर से डिफ्लेक्शन नहीं होगा। कब नहीं होता है, जब व्हीटस्टोन ब्रिज बैलेंस्ड होता है। तो यही हो गया फाइनल डायग्राम। हमारा जो क्वेश्चन मांग रहा था वो ये वाला हो जाएगा।
Two resistors 400 ohm and 800 are connected in series with a 6 volt battery. It is desired to measure the current in the circuit. An ammeter of 10 ohm resistance is used for this purpose. What will be the reading in the ammeter? Similarly, if a voltmeter of, let's say, 10,000 ohm resistance is used to measure the potential difference across the 400 ohm resistor, what will be the reading in the voltmeter? So suppose reading in this ammeter is capital I. So here capital I, that is current in the ammeter in the first diagram, can be written as total potential in the circuit, which is equal to 6 volt, and total resistance in the circuit is 400, 800 and 10. So 400 plus 800 plus we can say as 10 ohm. So from here current comes equals to 6 divided by 1200 and 10, which is approximately 1200. So this current comes approximately 6 cancels this 1200 by 200, so 5 by 1000, which is equal to, we can say as, let's say 0.005 ampere. So here this is the current in the first, let's say, part. Now coming to the second part, here it is being reading in the voltmeter. So reading in this voltmeter will be equal to potential difference across the, let's say, wire AB, that is 400 ohm. So we can say here current in the circuit I1 in this case will be given as, let's say 6, let's say volt is a total potential supplied by the, let's say, battery, and total resistance will be equal to 800 plus we can say this 400 and this 10,000 ohm will be in parallel. So this will be written as 400 into our 10,000 divided by 400 plus 10,000. So we can see here this approximately comes near to equal to 6 divided by, this will be, let's say, 400 plus 800 which is equal to 1200. So 6 by 1200 is approximately 1 by 200 which is equal to 0.005 ampere. But we are being asked to find the, let's say, reading of the voltmeter. So we can say voltmeter reading here will be equal to, let's say, potential, let's say 400 ohm resistor which will be given as I1 into 400 which will be here is equal to I1 as 1 upon 200 into 400 which comes equal to 2 volt. But here we can say this is the approximate reading, since in the denominator the resistance value will be, let's say, greater than 1200, so its exact value on calculation comes to be 1.95 volt. So here we can say option number 2, that is 1.95 volt will be our answer. So option number 2 is the answer.